Hey y'all, today we're going to be talking about factoring quadratic functions for a is greater than 1. So we want to factor functions that are in standard form, which just as a reminder, our standard form is that ax squared plus bx plus c. So the first thing we always want to look for, remember it's the first thing in both of our different factorings, a is equal to 1 or a is greater than 1, is we always want to check for a GCF. So we're going to start here with our first example. So factor 4x squared plus 26x plus 30. So if we look across, 4, 26, and 30 are all divisible by 2, but they are not all divisible by 4. So I can't take 4 out, but I can take 2 out of everything. So that will give me 2, and then I divide everything. So 4x squared divided by 2 would be 2x squared. 26x divided by 2 would be 13x. Oop, that's gross 13. And 30 divided by 2 would be 15. Okay, after I take my GCF out, my second step is to place my first term in my standard form. Remember, the GCF is no longer part of my standard form, so place my first term in the top left box and my last term in the bottom right box. So this is the same as what we were doing with our a is equal to 1. We take the 2x squared and we put it in the top because ax squared always goes in the top left. And we take the last term, our c term, and we do put it in the bottom. So 15 goes down in the bottom right. All right, step 3, we want to split the middle term into 2 parts. So we're going to be finding 2 values for the middle term. And to get those 2 values for the middle term, we're going to be 2 things. We're going to multiply our a times our c to get our a times c. And then we're going to find 2 numbers that multiply to a times c and add to our b. So our a and our c in this case is 2 and 15. So 2 times 15 is equal to 30. Okay, so 30 is our a and c. So we're going to list down our factors of positive 30. So factors of 30 are, of course, 1 and 30, 2 and 15, not 4, but 5 and 6, or sorry, 3 and 10 before we get to 4. Then, of course, 5 and 6, and now we're met in the middle, so then it's 6 and 5, so we're good there. Okay, so remember, these are factors that multiply to make 30, which is our c times a. Okay, then we want to add these factors to get our b. So now we're going to take these and we're going to add them across. So 1 plus 30 is 31. 2 plus 15 is 17. 3 plus 10 is 13. And 5 plus 6 is 11. And I want to match that with b. My b is 13. So these are no good, but 13 is good. So now that I have 13, that 3 and that 10, that is our split apart b. So in our original one, b is 13. So I now take 3 and I take 10. And like my step says, I place one part in the top right box and the other in the bottom left box. And you want to add in here with x. So I take 3 and 10, doesn't really matter. I can do 1, or you can switch it around. It's still fine. So I get 3x and I get 10x. Okay, and that is our split apart b. Then step 5, I want to factor out the GCF from each column and from each row. So over here, okay, I'm going to start over here on the left side. So my row here is 2x squared and 3x. So what is my GCF of positive 2x squared and 3x? Well, 2 and 3 are both prime numbers, so I can't take any number except for 1 out of both of those. But x squared and x, I can factor out an x. So I can go ahead and put an x out here on the outside. Then 2x squared and x, so now I'm going to do this first column, 2x squared and 10x. So 2 and 10 are both divisible by 2, so I can take a 2 out of both of those. And x squared and x, I can take an x out, so now I have 2x. And just to check, now that we've gotten our 2 outside of our first box, is x times 2x equal to 2x squared? Yes, so we're still good there. Okay, then we can do our next row down, so 10x and 15. So 10x and 15, I don't have x's in both, so I'm not taking an x out of this one. 10 and 15, though, I do have are both divisible by 5. Okay, nothing larger than 5, but both divisible by 5, so I can put a 5 on the outside. And then lastly, our final column, 3x and 15. What are 3x and 15 both divisible by? No, not both x's, so I can't take an x out, but they are both divisible by 3, so I can take this 3 out. Okay, now just to check when you're done, y'all, you want to check and make sure everything still multiplies correctly. So x times 2x is 2x squared, x times 3 is 3x, 2x times 5 is 10x, and 3 times 5 is 15. So 2x plus 3 and x plus 5. So for our final answer, remember, never forget your GCF. So we have 2 parentheses 2x plus 3 parentheses x plus 5. And remember, it does not matter which order you write your factors in. Okay, and that is, of course, our step 6. Group binomials across the top and group binomials down the side, and write it all in factored form. Okay, so pretty straightforward, y'all. Kind of very similar steps to what we did last time, except you have to do a little more thinking to find your values that go on the outside as opposed to our a equals 1. You can kind of just be like, okay, factors of b, that add up to c and a, and it's usually pretty straightforward. But this one with that a greater than 1, we do have to multiply the ca, and our factors don't necessarily become the numbers on the outside. Okay, so let's factor 6x squared plus 21x plus 9. So step 1 is we do want to check for that GCF. 6, 21, and 9 are all divisible by 3. They are not all divisible by 6, though. So 3 is going to be our biggest number we can take out as our GCF. So 3 taken out leaves us with 3x squared plus 7x plus 3. Ooh, sorry. First one is 2x squared, not 3x squared. That's me being crazy. Okay, so 2x squared plus 7x plus 3. So once again, I want to take that a term and put it in the top, so 2x squared. That c term and put it in the bottom, so 3. Then I'm going to do my c times a, so 2 times 3 is 6. And of course, our b is 7 this time. So we want factors of 6, 1 times 6, and 2 times 3. And then I'm going to take those factors of 6, and I'm going to add them to get b. So 1 plus 6 is 7, which is what we are looking for. So right away, I don't even care what 2 and 3 make. 7 is what I was looking for, so I can go ahead and stop. I don't want to do more work if I don't have to. Okay, so 2 and 3, remember I add x to them and I stick them in the top right and bottom left box, so 2x and 3, or not 2 and 3, sorry, 1 and 6. And I'm making some mistakes on this one, so 1x and 6x. And then just like last time, I'm going to factor out of each row and each column. So let's start with our top row, 2x squared and 1x, 2 and 1, both prime. Biggest thing I can take out is 1, but I can take an x out of both, so I will go ahead and take x out of both. Okay, 2x squared and 6x, I can take an x out of both, and 2 and 6, both divisible by 2. So 2x goes up on the top. All right, moving down to our bottom row, 6x and 3, those are both divisible by 3, so I can take a 3 out of both of those. And then final column, 1x and 3. I can't take anything out of that, so that's just going to be a 1 up in the top. So if I can't take anything out of my terms, then my GCF is just 1, okay, which is still a number we can multiply. Now let's check to see that everything works out. 2x times x is 2x squared. 2x times 3 is 6x. X times 1 is 1x. 1 times 3 is 3. And of course, 2x squared, 2x squared. 1x plus 6x is 7x. And 3 is 3. So everything matches up. So our final answer, don't forget your GCF. So 3, parentheses, 2x plus 1, parentheses, x plus 3. All right, y'all, let's keep going. Okay, number 3, 10x squared plus 15x minus 10. Okay, so once again, first thing we want to look for a GCF. 10, 15, and 10, all divisible by 5. Not all divisible by 10, though, because obviously 15 can't take out of 10. So I can take a 5 out of all of these. So 5, parentheses, that leaves us with 3x squared. Sorry, not 3x squared, did it again, 2x squared plus 3x minus 2. Okay, then once again, I want to do c times a, so 2 times negative 2 is equal to negative 4. And then my b is, of course, 3. Okay, so negative 4 is our CA. So remember, when our C value is negative, okay, then I need to list both the positive and negative root. So I'm going to double up on all of my roots. So negative 4, of course, can be 1 and negative 4, but it also can be negative 1 and 4. And then 2 and negative 2, which I don't need to list 2 and negative 2 as negative 2 and 2 because that's the same thing. So luckily, if it's the same factor, I don't have to list it twice, right? And then, of course, we are adding these to get b. So 1 minus negative 4 is negative 3. Negative 1 plus 4 is 3, which is what we were going for. So we can stop there. We stick everything in our box. So 2x squared, negative 2. I split up negative 1 and 4, so negative 1x and 4x. And then we are good to go. Let's start factoring. So 2x squared and 4x, I can factor out a 2 and an x. So 2x. 2x squared and negative 1x. 2 and 1 are both prime, so I can't take anything out of that, but I can take an x out of both. So x comes out here. Okay. 4x and negative 2, both divisible by 2, so I can take a 2 out here. And then negative 1x and negative 2, both are prime, but I could take a negative 1 out of both of those. So negative 1 goes on the outside. Okay, so let's check to make sure everything's good. 2x times x is 2x squared. 2x times 2 is 4x. X times negative 1 is negative 1x. Negative 1 times 2 is negative 2. And just to check, 2x squared, 2x squared. 4x minus 1x is 3x. Negative 2 is negative 2. So everything matches up. We did our job. So GCF on the outside, 5. X plus 2, close parentheses, and then 2x minus 1. So hopefully y'all are kind of getting the hang of this, kind of getting it, okay? Starting to make a little bit of sense. GCFs, if you've noticed, are really, really important in this one. You do it in the first step, and you do it in all of your factoring step on the very end, okay? So you do really need to know your GCFs to be good at factoring a is greater than 1. Okay, so let's factor 24x squared plus 4x minus 8. So 24 is divisible by 4, 4 is divisible by 4, and negative 8 is divisible by 4. So 4 is our GCF. And of course, y'all, I always look for the smallest number in my list of factors, and that's kind of the number I work my way up from because I'm never going to be able to take a number bigger than 4 out. So 4, I work from 1 to 4. And of course, in this case, we can take 4 all the way out. So 4 parentheses, 6x squared plus just 1x, and then minus 2. Okay, so as per usual, we take our a squared term and put it in the top left. C goes in the bottom right. C times a, so 6 times negative 2, which equals negative 12. And then, of course, b, which in this case is 1. Okay, so once again, we have a negative c and a positive b. So we want to list out our negative and positive factors. So we're going to have to double up here, and then we want to add up to positive 1. So negative 12, we of course have 1 and negative 12, as well as negative 1 and 12. We have 2 and negative 6, along with negative 2 and 6. And we have 3 and negative 4, along with negative 3 and 4. So adding these all up and across, 1 minus 12 is negative 11. Negative 1 plus 12 is 11. 2 minus 6 is negative 4. Negative 2 plus 6 is 4. 3 minus 4 is negative 1. And negative 3 plus 4 is 1, which is what we're looking for. So it took us a little longer this time, but we did find it eventually. So negative 3 and 4, we split up with our x's. So negative 3x and 4x. Okay, then from here, I'm factoring out 6x squared and 4x. I can take an x out of both. I can take a 2 out of both. Can't take a 3 though, can't take a 4, so 2x it is on the outside here. Okay, 6x squared and negative 3x, I can take an x out of both, and I can take a 3 out of both, so 3x out here. Okay, 4x and negative 2. Can't take an x out of both, but I can take a 2 out of both. So we get 2 out here on the outside. And then negative 3x and negative 2, both prime, so I can't take a number out, but they are both negative, which means I can take negative 1 out. So then we get the 2 factors plus our GCF, so 4 in the front, then 3x plus 2, along with 2x minus 1. All right, y'all, and that is factoring a is greater than 1. Okay, so the real key things to remember between factoring a is greater than 1 and factoring a is equal to 1. You're still following all the beginning steps, GCF, multiply c times a, list your b, splitting apart factors of c and a, adding them up to b. But once you find those factors, instead of sticking the factors on the outside of the box, like we do for a is equal to 1, we stick the factors on the inside diagonals of the box, and then we GCF our way out to get our numbers on the outside. So that's the slight difference between a is equal to 1 and a is greater than 1. Okay, but other than that, this closes us out on factoring, y'all. See you in class.